Hi everyone, Dan Baskett from Tanzu here. Are you ready to explore building intelligent apps on the Tanzu platform? We're talking LLMs and agentic AI, systems that don't just chat, they take action. But honestly, integrating agentic AI is pretty tough, but becoming more and more vital. So Tanzu's platform philosophy really hasn't changed. We simply treat AI like any other app for speed, security, and efficiency. There's a couple key enablers that make this pretty seamless on the Tanzu platform. We support standards like Anthropic's MCP, Model Context Protocol. In fact, we provide the official Java SDK for MCP. And then there's Spring AI, which empowers the vast pool of Java developers to easily build these powerful agentic capabilities right into their existing apps. All that wrapped up in an integrated platform approach helps Tanzu customers deploy real AI solutions real time. Let's see how that works. So for this demonstration, we're going to look at the Acme Fitness app, all running on the Tanzu platform. As you can see, it's a pretty standard e-commerce application, front end, catalog, identity services, payment, orders, carts, back-end services. But the technical goal of this project is to add an agentic AI assistant, meaning it securely executes back-end actions via MCP servers, going beyond simple LLM Q&A chatbots. Tanzu Platform provides the capabilities to manage this complexity effectively, and this will enable us to do a phase development. Knock out 3 phases. Phase 1, LLM integration. Here, Tanzu can simplify this easy and secure connectivity between app and foundational models, enabling the developers to rapidly iterate on the application. Phase 2, model iteration. Tanzu offers the flexibility to deploy and manage a diverse set of models. So when you go from development production, you can change the model easily with just binding a new model that's available. And phase 3, adding agentic tools. Tanzu enables the controlled agent interaction via APIs and services, via robust networking, security, and service discovery. So let's focus specifically on phase 1 and see how Tanzu Platform facilitates this initial LLM integration. So let's take a look at things from the platform engineer perspective. Here we are in the Tanzu Platform interface, where the platform engineer provides the necessary AI model access for the Acme Fitness developer. Remember, the goal here is rapid iteration, so we're going to initially deploy a model instance configured to run efficiently on ready available CPUs as opposed to GPUs. And this gets the developer unblocked in just a matter of minutes and doesn't require provisioning GPUs or even acquiring GPUs. First, the platform engineer selects the specific model required. Then they can enable necessary capabilities for the instance. For our scenario, they'll enable chat for the basic interaction and enable tools capability, anticipating the need for agentic actions using MCP in later phases. Next, they provide essential configuration details specifying location or the registry where to pull the model artifacts, along with any specific host configurations needed for the virtual machine that'll run the model. Now, even for a CPU-based model primarily used in development, applying usage controls is probably a pretty good idea. So within the service configuration here, the platform engineer can set some sensible upper limits on requests per minute or tokens per minute to govern the developer usage. Next, they can assign a descriptive service name to the provision model instance. This identifier is what the developer will use when they go to bind the model to their code. And to prepare for enhancing the chatbot with RAG, Retrieval Augmented Generation, later on, the platform engineer will also provision access to a second specialized embeddings model as part of the process, as well as a Postgres instance. This embeddings model is necessary for generating the vector representations of the Acme Fitness data. This allows the chatbot to provide contextually relevant, company-specific answers. So what's this look like from the developer's perspective? Well, the developer is building their AI assistant using Spring AI, which integrates seamlessly with their existing Java and Spring ecosystem. This allows them to focus purely on the application logic. They can implement the chat features, the agentic features, all because Spring AI abstracts away all the low-level integration with the AI models. And then deploying to Tanzu Platform is equally streamlined for them. They define the app settings in a manifest. They log into the system. Then it's a simple CF push command that triggers the platform to automatically build, deploy, and run the application. Connecting to backend services is next. The developer uses the platform's marketplace to find the provisioned LLM instance and the Postgres instance needed as a vector store for RAG. Then they can bind these services to their application with the CF bind command. Tanzu Platform handles the rest, securely injecting connection details and credentials directly into the app's environment, removing all those burdens from the developer. During Phase 3, the AI assistant evolves from an informational tool to an actionable tool by integrating MCP servers. These servers, running as bindable services on the Tanzu platform, expose backend functionality like inventory checks or order placement as discrete tools. Acme's teams already developed MCP servers for key services like catalogs and ordering, potentially using Spring AI or other supported frameworks, although third-party services can also be integrated. By binding to these MCP services, natural language interface gains direct access to executing tasks like confirming stock levels, determining shipping logistics, or placing customer orders, thus fulfilling complex requests completely end-to-end. Now that we have the app running and it's bound to our backend MCP servers, we can test the functionality. As we enter data into the chatbot, you can see the MCP tools allow us to go far beyond the typical chat assistant and add specific functions that enable natural language interface to perform actions based on that interaction. Now with the application tested and running, we're ready to move to production. We know in production we're going to need the performance of a GPU-backed model, so we can select one running on VMware Private AI, and then make that model available just as we did before with CPU-backed models. Then the application can bind to this new instance, and we're ready for production workloads with no application changes. So to quickly wrap up, we saw how Tanzu Platform enables the iterative development of a truly agentic AI assistant for Acme Fitness, one that securely took action. Tanzu empowered platform engineers with rapid, flexible model provisioning, like CPU for dev, while Spring AI, CF push deployments, and automated service binding streamline the developer experience. This integrated approach tackles the key integration and operational hurdles that stall enterprise AI deployments. By treating AI like any other workload on a unified, secure platform, Tanzu enables faster iteration, easier management, and controlled access to the tools and data that agentic AI requires. In short, Tanzu Platform offers an efficient and secure path to production for impactful agentic AI applications that drive real business value.